One important concept in Chapter 1 was the difference between a random sample and a simple random sample. To sample a population, I divided the dolls into 3 groups, randomly chose one of the groups, and then surveyed all of the members of that group. So here's what I did. Suppose I wanted to see if my daughter's toys are in working order, but I didn't want to check all of the dolls, I just wanted to take a sample. So what I did is I grouped all the dolls in according to what type of doll they were. Here I have the baby doll group, over there's the potato head group, and here are the 3 Elmo toys. If I wanted to know what percentage of my daughter's toys are in working order, I could randomly select one of these groups. I'm going to do this randomly by rolling a die, a 6-sided die. If I roll a 1 or a 2, I'll sample the baby group. If I roll a 3 or a 4, I'll sample the potato heads. And if I roll a 5 or a 6, I'll sample the Elmo group. So here we go. Here's the roll of the die. Oh, there's the die. I rolled a 5, so that means I'm going to sample every member of the Elmo group and check them to see if they are in working order. Ooh, Elmo, do you work? Uh-oh, the button on this Elmo doll doesn't, oh, my dog has the doll now. But anyway, that's one that didn't work. And then the other 2 are in working order. Let's check this Chicken Dance Elmo doll to see if, uh-oh, maybe I have 2 that aren't working. Chicken Dance Elmo. Oh, I have 2 out of 3 dolls that are not in working order. We surveyed the Elmo dolls. We found that 2 out of 3 were defective, and so our statistic was p-hat, which stands for the proportion or percentage of defective Elmos, was 2 out of 3. But going back to how we collected the data, did we collect a random sample? And in this case, when we grouped the dolls and then surveyed everything in the group, the chance of any doll in the population to be included in my survey was 2 out of 6, because each group had 2 numbers on the die out of 6 numbers on the die total. And so everybody had a 1/3 chance of being included in the survey. But when it comes down to a simple random sample, we have to think a little more intricately.
Edie's in the way.
Edie, you're in the way, so we're going to have to move you. And we know that we didn't collect a simple random sample because every group has to have the same chance of being included. And in this case, a baby doll had no chance of being in a group with a potato head, and they had a 100% chance of being in a group with another baby doll. So the probabilities are not exactly the same, so you don't have a simple random sample. Another way to have collected a sample would be to suppose this group of toys represents all of my daughter's toys. This is the population of my daughter's toys. She only has 6 toys. And if I wanted to collect a sample and see if the toys are in working order, let's say I wanted a sample of size 2, what I could do is give each toy a number. The potato head on the left, I will call that one. We'll call number 1, 2, 3, 4, 5, and 6. Then I will randomly draw a number between 1 and 6. So I'm going to roll the die again. And the die came out to, whoa, a 5. Maybe this die isn't so random. So that means I'm going to test that potato head on the end there. And I'm going to test number 4 and see if there, thanks Edie, and see if there's Edie and her dolls, and see if they're in working order. So let's test them. Here's this Elmo. Oh, he works when I squeeze him. It tickles. And this potato head is missing some parts, so I think he's not necessarily in working order because he's missing his arms and his hat and some other parts. So the statistic in this sample was the percentage of dolls not working was 1 out of 2 or 50%. But the question again, how we surveyed, was this a random sample? And the chance of any element in our population of 6 dolls being selected, because the doll was a fair die, or the because we rolled a fair die. We had a 1 in 6 chance of selecting any of these dolls. The next question, Edie. The next question, was this a simple random sample? And if from chapter 4 we learned about combinations, and we know that there are 6 choose 2, which is 15 groups possible, and each group, again because we rolled the fair die, had a 1 in 15 chance of being selected. So this is a simple random sample. So yes to the random sample, and yes to a simple random sample. Again, the big idea is a random sample is not necessarily a simple random sample, but a simple random sample is always a random sample.